Welcome to the Developers Podcast. In this episode, we're talking about the AWS SDK. Good morning. Thank you for downloading the AWS Developers Podcast. We're available in all good podcast applications every Friday morning. Subscribe, leave us feedback, put a thumbs up or a little star so that we know what you love about this type of content for developer. Today, my guest is Trevor Rowe. I hope I pronounced your last name correctly, Trevor.
You did great. Thank you.
Senior Manager, Customer Experience Team. You're in charge of the SDK, the Software Development Kit. Maybe we can start. I assume most people know what is an SDK, for this audience at least. But what is your definition of an AWS SDK?
When we talk about the AWS SDKs, we speak primarily about the low-level clients that provide API access to the AWS services in all of our different supported languages. There's roughly 380 AWS services, 14,000 plus API operations, and we build GA SDKs in 13 languages, inclusive of
13 different languages.
Yeah, it's a lot. Yep.
It grew up from, I remember a few years ago when I started AWS. Okay, it was more than 10 years ago, and you've been there since 14 years. There was only Python. I think it was the first one.
No, not Python, actually. The first one was .NET, believe it or not.
.NET?
.NET, followed by Java. And then we did PHP, and Ruby was the fourth one. I was hired to work on a Ruby SDK.
It was more than 10 years ago, and from there it evolved to 13. Can you name the 13? That's the challenge.
I can, actually. And when I say 13, that's inclusive of PowerShell and CLI. So we've got Java, JavaScript, Python, Ruby, PHP, Go, Kotlin, Swift, Rust, .NET, and I'm missing one.
C? You mentioned it
C++,
already?
thank you.
C++.
C++. And then we have inclusive of that, obviously the AWS CLI, AWS CLI for PowerShell. And then we have lots of other tools that we build, that support the SDKs.
That's probably one of the primary library the AWS developers are using. You learn a new service probably by clicking a bit in the console, but very quickly, if you're a developer, you're going to download the SDK for your favorite language, or your favorite package manager, npm install, pip install, whatever. And that's the first contact. So that's why this group, your group, is attached to the customer experience, developer experience team.
Yep. We work closely with both the console teams and the doc teams because a lot of customers, their first experience, they might start in the console, but then they're dropping down into the documentation, into the CLI, or into their favorite programming language SDK. And so we have been working in CX now for a couple of years, and it's a good group.
320 plus services. Thank you for providing a count, because it's very difficult to get the number of services from AWS, depending who you ask, and then different teams in 13 different languages. So can we summarize saying the scalability of this project, generating, maintaining, developing the SDK is your biggest challenge?
Scale is the biggest challenge. Early on in my career, we were building, API updates into our SDKs by hand. And, we'd release an update once every other month for a service. There were 5 services. That
different time.
It's a different time. Now we're publishing 1,500 API updates a year through the SDKs. And so it is paramount that we can, through automation, code generation, and a variety of testing best practices, scale to meet this. So we rely heavily on a lot of internal tools and technology, a lot of which we make available open source, like Smithy for code generation, or code generation off some other model formats. We have internal applications that manage the lifecycle of an API from inception from the service team through preview builds and validation, backwards compatibility checking, linting, approvals, release scheduling, collection of release notes, and all the way till when it makes it out to GitHub and your package manager. So
you said
yeah,
at the beginning we generate them, we wrote them manually, but okay, there were 5 services, and so I guess the opposite is to generate them automatically. Can we dive a bit into
sure.
that generation? How does it work? What is your starting point as an SDK team?
Yeah. Amazon has adopted a model first kind of paradigm. So if you're familiar with OpenAPI or Swagger and technologies like that, we have internal technologies and open sourced ones. Smithy is the primary one. And it's an interface definition language that the service uses to define the public interfaces, the inputs, the outputs, the exceptions, and it is layered with metadata. And that model plus metadata can code generate a lot of the service scaffolding, but we also use it to code generate the client scaffolding. And so that's the primary technique that we use to generate all of the types and serializers and deserializers for all of these AWS API operations.
I talked recently to a customer that was using Smithy to define their own API and to generate their client for their API, just like we do as well. Can you share a bit of reasons why we invent something new and not use OpenAPI? I guess there is a matter of complexity and the quantity of our APIs.
Yeah, some of the primary flexibility that we lacked was the kind of what we call trait-driven behaviors, or ability to define our own behaviors through these traits. Also, by owning that specification, it's given us a lot of flexibility to be opinionated on the tooling that we built. And we've shared the tooling, and like you said, a lot of customers have used it, and we take that feedback and we incorporate it. Our goal is to make Smithy a tool that can generate SDKs for all customer use cases. And so it's not strictly an AWS technology. We try to keep those AWS bits and opinions kind of isolated from the generic Smithy concerns. But yeah, it's really been a tool that helps us to scale. It helps us generate our documentation. It helps us generate our IAM policies. It helps us generate our CloudFormation integrations. Like this whole, strong interface plus behavioral traits, allows us to scale a lot of these things through code generation.
And I keep saying to customers that the API is the source of the truth. At AWS, when we start a new functionalities, a new capability, or even a new service, we start by defining what is the API, what is the contract. I didn't realize that the service team uses Smithy to scaffold part of the internal of the service as well, like the front end of the service, I guess, is generated by that. So it's really pervasive. You mentioned documentation, SDK, tooling, IAM permission, part of the service as well. Is Smithy under your responsibility as well, or we have a different team at AWS to manage it?
Smithy started as a hackathon project internally from SDKs, and it's still part of our org. We work very closely with our service frameworks team internally, but it started as a way for us to be able to generate better SDK clients. And so, it was a superset of our previous interface definition language used internally, but now it's the default for all new services. I mean, there's tens of thousands of internal packages using Smithy today. So it is,
But code generation is only one part of the problem. As a developer, I don't want to use an SDK which is entirely generated automatically, because none of the idiomatic aspect of my favorite language will not be there. And sometimes the AWS API might be very efficient as an API, but it's not easy to represent the data structure in a specific programming language, or it's a bit convoluted, like there is a structure inside the structure inside the structure, which is an enum, which makes code a bit verbose to write from some programming language. I'm thinking about all strongly typed programming language like Java and Rust and Swift, for example, or Kotlin. So what else? And what are we doing on top of the generated code to provide a better developer experience?
We look at the generated code as kind of the most important baseline experience, because anytime we layer on top of something with an opinionated interface, we're going to be abstracting away details of the lower level API. And customers always need that escape hatch to be able to access the full power, full breadth of an AWS API. So we're never not going to do, this one-to-one parity of every API. That's very important. But a good example is S3. In almost every SDK, we have higher level libraries wrapping S3 that do everything from synchronized local and remote file systems, right? When I say file systems, S3 object storage, or they do large object transfers, intelligent, multi-threaded concurrent uploads with checksumming of large objects. It's a lot of the data plane services. DynamoDB, we have object mappers and object relational store interfaces that make using DynamoDB a little more natural in the local language. And we see a lot of return on investment in focusing in those areas. It's a difficult thing with the size of our teams and the number of services. We can't scale our team size to match the number of services. So, these higher level libraries, and I would even say the lower level libraries are where we focus our efforts on. The code generator interfaces we're very confident with. It's the bits below and above that take up more of our focus.
And these parts are written manually. There is no automatic secret sauce to generate that code. It has to be idiomatic for the language.
It does.
And carry a sense of semantic as well.
It does. We work really hard to try to make the SDKs behaviorally compatible, because, as a developer, most of our developers using AWS use more than one of our languages or tools. And it's just, it's the nature of development. And so it's very important to us that if they configure an environment or an AWS config file with a particular source profile and assume role and environment variable override for certain behaviors, that when they deploy something that uses Java and Python, that they're going to behave the same. So a lot of our challenge is reconciling those historical differences as we've standardized our behavior there while maintaining backwards compatibility. There's the long map where, we look forward to the future and, as SDKs are major versioned and, we find natural points where we can change default behaviors or backwards compatibility, for that next major version, we can reconcile those. But that's kind of the biggest thing, is managing the complexity of consistency across our SDKs.
One good example, I think it's very consistent, but you will tell me, it's the way the SDK finds AWS credentials. So there is that concept in the SDK of identity resolver or credential provider. I think both terms are used. And there is some intelligence in all the SDK that I know. I hope it's all the SDK to look for AWS credentials on my local machine. If it is on a local machine, then maybe in the IMDS, the metadata for EC2, and then in environment variable for Lambda. So as a developer, I can write the same line of code and deploy indifferently to a container, an EC2, virtual machines, a Lambda, or even running on my laptop. And I'm quite confident most of the time the SDK will pick up the right credentials at the right place. But this is something you have to implement consistently across all the SDK and manage manually.
Yeah, it is. And we have, right now we're investing in internal tooling and automation to try to assert those kind of things. So
what do you mean by assert?
Test automation that could, orchestrate all 13 of our SDKs, set up a fake environment, and then monitor the requests that they've marshaled and assert things against, make expectations or assertions so that we can track compliance of this and identify these things through a kind of a a centralized interface. Like we're working on tooling like that. We're also last year we went down this. Actually, it's been a year and a half now, and a Smithy SDK reference architecture for AWS. We have basically this internal, almost like an SDK Bible of how you should architect a modern SDK. What are all the behaviors and what are all these extension points, right? Like, what is an auth interface? What is a retry interface? What is the telemetry and metrics reporting interfaces look like? What are the interceptors that a user should be able to hook into and to modify a request, and what capabilities should be exposed and should not be exposed? And over time, we're trying to get SDKs closer and closer to adopt that idealized interface. So some of our newer SDKs, that have been released more recently, Rust, Kotlin, Swift,
V3.
JavaScript V3. Well, even JavaScript V3 came out before the SRA. Okay. And so, but we have been retrofitting it with almost all of the SRA interfaces. And so the idea is that even if we didn't do it in a way that's going to suit your business case, you're not prevented from modifying the core behavior of this underlying SDK. And so that's another area we're spending a lot of time in.
So there is a lower level, like it's the one-to-one match with the API. Then there is that intermediate level where we provide some default behavior, but as you said, it's important to be open and to let the developer change that behavior or customize the behavior. I guess different developers in different industries have different use cases, have different needs.
Yep.
And you mentioned authentication resolver, telemetry you mentioned as well.
Yep. Telemetry, everything from logging, telemetry, retry behaviors, authentication, authorization. We have this concept called interceptors where you could basically inject code that is executed at any part of the request lifecycle, from validation to request building to, and you can kind of modify the request at any part. HTTP transport, so you could even swap out the transport library for something that you need. Endpoint resolution is another one of these kind of standard interfaces that you can drop in replacements for. There's probably a couple more, but those are the primary ones.
Yeah, it's important. The endpoint for testing, for example, if I want to test against a local stack, I need to be able to swap my endpoint very easily. You have other use case or example of such configuration?
Yeah, we have endpoint resolution is one of those things that sounds like it should be really simple, but in actuality, it's not. We have an endpoint rules engine that says, given all this information, here's how I construct an endpoint. And in the normal case, this is really straightforward. Right, you could essentially templatize it with like service.region. Amazon AWS.com.
Right. Yeah.
And that sounds great. But not every service is regionalized. Some are partitional, single endpoint per partition. Some have partitional and regional endpoints. Some of them have different endpoint prefixes based on the request that you're making. So you can imagine that a parameter in the request might be the ID of a resource, and it needs to take you to a cellularized endpoint. And that's just the first of many, And so as the need to route requests based on context of an individual request, has made endpoint resolution much more complicated. But for some customers, that complexity is not needed, or they want to completely overwrite it for local testing or mocking. And so being able to sub out this behavior, either just through simple configuration, like an environment variable or shared config file, all the way to they just want to sub out the entire endpoint resolver and put in their own logic. That's possible too.
You mentioned that all the SDK are not generated automatically with Smithy. There are still older SDK, and we have some legacy as well. Is there any big difference from a developer perspective by using these new Smithy generated SDK versus the older one?
Most of our newer Smithy generated SDKs, we've been moving towards modularized versus monolithic. So, there's some differences there. We have a slightly different approach for serialization, deserialization. But underlying, no, the behavior of the SDK largely should be the same. I think Smithy introduces a little more type granularity. We have tagged unions in the Smithy-based SDKs. Those get represented more simply just as structures with members in the non-Smithy SDKs. So to the end developer, it should really be opaque whether it's being powered by Smithy. Some of the other interesting things, though, are some of our older SDKs were fully dynamic in that you could drop a JSON file into a directory somewhere and it would just like manifest a new service, right? And
Like Python, for example?
Python, for example, yeah. And there's some really cool benefits to this. Some of the things, though, that our customers have let us know that they want to have some of the more modern typing features of Python that doesn't really afford, better integration with their IDE, validation and mocking frameworks would be better suited with stronger types. So, we're actually working on it's available on GitHub now, a new async SDK for Python. Right now, we're focused primarily on building out support in Python for those APIs we don't support in Boto 3 today. So Boto 3 covers most every AWS service and operation, but because of limitations in our HTTP transport stack and its architecture, we can't support things like bidirectional asynchronous event streaming. I think support for async has been the number one request from customers. And so rather than try to just replace a synchronous blocking, modernization of Boto 3, we're focusing on that gap, the async bidirectional event streaming HTTP 2 support. I think if I was to kind of gaze into a crystal ball, our intention is to then also supply or support blocking interfaces like Boto 3 on the modern code base. But, Boto 3 exists today, so there's no rush to go replace that. Customers use it, largely they like it, and, we know what some of those warts are, so we're trying to address those warts in the new version. But, support for Boto 3 is not going away anytime soon, so...
That's a nice segue to my next question about maintenance, and backward compatibility. You mentioned 13 different languages, 320 different services, new release almost every week, at least for some service like Bedrock for the moment. How do we maintain the past version? What is the policy? How many past versions do we maintain in terms of security? What is the life cycle? Are we announcing the expiration or the sunsetting of an SDK a long time in advance? How does it work?
Yeah, so we generally try to avoid major version bumping our SDKs. We find that to be very disruptive to us internally, it's disruptive, and we know it's also disruptive to other developers because then it forces the question of, do I upgrade? Do I have to upgrade? What's the opportunity cost of not upgrading? When's security and major bug fix patching going to go away? And so we try to support most of our SDKs as long as possible. Some examples: Boto 3 has been GA for I think 12 or 13 years. It's been a long time, and it's going to be supported for a while longer. Java V1, is equally. I think it's 10 plus years. We have Java V2. We only recently announced that Java V1 is entering maintenance mode, which means we're going to stop. We're not going to add new features, but we will fix bugs in security vulnerabilities. And the kind of working thought here is, if we don't put a date on it saying that we're going to end support at some point in the future, there won't ever be an urgency for people to look at this problem. But we also know that when people look at this, they're going to come back to us and say, hey, I can't migrate because of this, or It's more effort than you think it might be. Can you give us more time? We're definitely listening. We're fielding those conversations now. We're not going to rug pull anything. At the same time, we're also investing internally very much effort into building tools and automations that help customers migrate automatically. So we have some of these available today for both JavaScript V2 to V3, Java V1 to V2. We're still investing effort, especially into our Java tooling. We have internal targets and milestones of, how successful and how many of the code bases. We have a really large corpus of code internally to experiment with. And so we can test these code migration tools on tens of thousands of packages.
We are the first customer of the SDK.
Yeah. And so that allows us to refine that. And so we're not going to ask people to do the impossible, and we're going to do whatever we can. But after a while, it becomes necessary to kind of to end support for an older version. But our working philosophy is we know that that's disruptive, and we want to minimize that. Moving forward, for most of these SDKs, we're trying to, the SRA and the extensibility interfaces, modularization, these are all strategies that are going to allow us to version at component levels and maybe avoid some of these major breaking changes, even further, right? Like we don't want to do lots of major versions. And where we do make backwards incompatible changes, we really try to limit those to things that are either break fixes or where the default stance of an SDK is actually harmful or dangerous for new users. Like we don't want to leave a sharp edge that if you're not aware of this is going to put your application in a state where it's making cross-region calls or, something that is really not ideal. And so sometimes we will make the hard decision to do that. In January, we announced, that we're both improving the default retry strategy on a handful of SDKs. We have a blog post out there. I can try to get you a link, and you can add them to the show notes.
In the notes of this of your podcast app. So if you scroll down a bit in your app, you will find the link.
Perfect. But yeah, we're improving our default retry strategy, and we're migrating STS clients, for those 3 SDKs that don't already, to use the regional endpoints instead of the partitional one by default.
Oh yes, I saw that. It's a big change coming in the coming months and years, changing the STS that use STS is the service that distribute the token, the security token.
Yep.
It used to be central, and now it is going to be regionalized. That's correct. That's the idea.
That's the idea, and largely, most customers we assert are going to be unimpacted by this change. But we're really cautious because we know that there's always some interesting edge case where somebody has some behavior and some observable, side effect of, the length of the session token that's returned between the public or the partitional endpoint versus regional ones, and so we don't make those changes lightly.
Yeah, given the number of customers we have and the different use cases and the crazy things they built on top of AWS, I guess there are tons of edge cases. And as you said, for the majority of the customers, the change will be unnoticed. But for some tiny percentage, we have to be extra careful. Going back to Smithy, I noticed that some SDK, at least the one I'm using the most these days, which is the Swift SDK, expose some Smithy construct and package to the user as well. Should Smithy be an implementation details and hidden from the user land?
So from an architectural perspective, Smithy is meant to, at least when we're talking client SDKs, right? Mm-hmm. Like the not the IDL, not the Smithy IDL or the Smithy code generation tools or all those. But for most of our languages, we have a Smithy Swift or Smithy JavaScript or Smithy whatever. And those packages implement a lot of the core components that you need to assemble an SDK. So they'll implement kind of your
The
your middleware
authentication, the
stack.
credential management, typically.
Yeah, well, and they won't even implement those. They'll
Mhm.
implement a generic SDK that says, I'm going to take a request and I'm going to run it through a serializer, deserializer, and then I'm going to ask whatever the auth provider is, so there's an auth provider generic interface to apply auth to this request. But the actual implementation of that auth provider might be an AWS SigV4 signer and credential provider. And so the Smithy pieces are generic, reusable, extensible components. And so we do consider those kind of more public interfaces where a customer could, inject their own or, replace that component of the SDK. We probably are a little, inconsistent on our naming or branding of those components and maybe how they're exposed. But yeah, they're, we do look carefully at what parts of the SDK are made public because, once it's public, people will twiddle with those bits. And so
Yeah. Once it's public, it's out there forever. As you said, we cannot change it anymore.
Yep.
That's the lower part. On the upper side, if we look at end-user application development, there is a framework called Amplify that goes above and beyond the SDK to provide additional facilities for developers to interact with authentication, Cognito, for example, or persistence with S3 or REST API. Where is the line between what the SDK should provide and what this type of opinionated framework like Amplify should provide? How do you decide internally, this should be in the SDK and this should be in Amplify?
I think if you interviewed any of our SDK developers, there is a desire to provide more creature comforts on top of the SDKs. Where we have to draw the line sometimes, though, is just, where is the expertise and where do we have bandwidth? And so I think we draw that line mostly on the data plane heavy services where there's, some really broad, obvious, customer use cases that we can solve generically, but we do encourage service teams to build on top of the SDKs. And so, there's lots of like the KCL, the Kinesis client library, or
the location service also build their own SDK to make it easy to use their service.
Right, because for a lot of services, it's not just low-level API access that's important. Mm-hmm. It's the logic that, that combines these operations in a way that, can solve a job to be done. So for Amplify, they have a vision. Originally, they focused, primarily kind of in the mobile space, and they come from that. Yeah. Mm-hmm. Yep, and they come from that angle, and they dive much deeper in that space than we could. We can't be experts in every service, and so our job is to make extensible SDKs that can be wrapped, or applications can compose interesting things using this.
I like the idea of having service team providing additional SDK, higher level SDK to make it easy for developers, and we can see Amplify as a broad. It's not a service team, but they address specific categories of developers. It's the web developer or the mobile application developer. Location service, it's for one service. There is another service that is moving a lot these days. It's Amazon Bedrock around GenAI. There are new API models, parameter almost on a weekly basis for that service. Yep. And one of the challenge I have to interact with these with Amazon Bedrock specifically is that the API is very simple. If you look at the API for Bedrock runtime, there are like 4 or 5 APIs, but a big part of what they do is to take a payload coming from your application and give it to whatever large language model, generative AI model on the other side. And that's really, it's defined by the model, not by the Bedrock service team. So is there something where the SDK team can help to make it easier to manage these generic payloads that are not related directly to the service itself?
That is an excellent question. This has been a kind of a long-standing opportunity. And one of the areas that, again, I feel like a broken record saying this. We're investing and doing work now internally to try to solve for this problem. It's fundamentally that the SDKs are very good at providing typed interfaces to APIs. But if the API exposes part of its, request and says, and here's a blob or here's a string that just contains a JSON document, to the SDK, that's very opaque, and we just return bytes or return a string and then leave it as an exercise for the customer. We're not happy with that experience, and so what we're looking at is, can we, with the kind of collaboration from service teams, define schemas for the various types that can flow through these open interfaces? So if you look at what we do with Smithy code generation, we're trying to build tooling so that we can both collect the schemas from services and then generate these types and support runtime serialization, deserialization. So if I'm a user of Bedrock and I know I'm using this particular model, I can take the type that represents its inputs and outputs and work with it in a natural way, and then pass that object down to the SDK, which would then marshal it into the body of this, Bedrock request and remove some of that complexity. And we see opportunities for this increased typing in a lot of places that I'm going to call SDK adjacent. Some types that flow through the SDK's interfaces, but just through these, blobs or strings. But also things like Lambda events, VentBridge, objects written to S3 that have structure to them, SQS payloads. There's a lot of these things where there is somewhere a well-defined schema for this, but the exercise is left to the user. So that's definitely an area that we're investing in. I can't make comments or commitments to when this is going to come out. Yeah,
that was not my question.
Yeah, but
it's good to know that the problem is identified and the team is working on it.
Yeah, and so we absolutely do want to, but we have to work with doc writers to be able to document these things. We have to work with the service teams to collect the schemas. We have to have a mechanism to have those published. We have to solve questions like, do we package this as part of a specific service, or do we package these types into their own separate packages? So there's a lot of design that we're working through and everything, but it is an area that we think is worth tackling.
What are the other areas where you're working on? I know we cannot disclose any specific. You mentioned a few already. So this one, you mentioned a more modular architecture for some of the SDK, more pluggable behavior, configurable behavior for developers. Is there any other large area of thinking for the future of the SDK at AWS?
I mean, there's, one of the areas that we know that we want to get better at is even just having better, focus on performance and visibility into what the performance of an SDK is. So we know that matters to customers. Not every case, but in some case where performance matters, it matters a lot. And so that starts with having, increased, ability to monitor over time the deltas in performance from one SDK release to the other, but comparative benchmarks and or kind of specific investments that address performance. We do a lot of our performance related work today in the CRT. So, customers of Python or the AWS CLI or even Java are probably familiar. If they're not, they should look into this, where you can add a CRT. The common C runtime is what CRT is. It's a dependency that then puts performance critical parts of S3 requests through the CRT, and it can manage concurrency, auth, all of the crypto primitives, and do so in a way that, sidestep the Python GIL, for example, and we get much better performance. So, but we also want to be able to, not just in these instances, we want to be able to observe, micro changes in performance between language runtime versions that we publish, or when we update to the latest, version of Node or one of our dependencies. How does that impact Lambda customers? So that's an area where we've also spent a lot of time reducing package sizes in JavaScript, monitoring performance. So that's an area that you can expect to see more coming out, from the SDKs.
How developer can contribute or share feedback or report feedback to the team?
GitHub is probably the best place. We are, I know sometimes that can feel like I'm putting a needle in a haystack and will I get seen? But we do monitor GitHub, and we do look at these things, and any customers who come in with legitimate issues or contributions, we do our best. I would say that we're looking to double down our efforts this year in trying to be more involved on GitHub and in these spaces. So if you ever see me in public, come twist my arm if you don't think we've been doing a good enough job. Yeah, that's right.
So. Thank you, Trevor. And Trevor Rowe, you're senior manager for the SDK team at AWS, working with a small team, doing an amazing job of managing SDK to wrap 320 plus AWS services in 13 different language. That's quite amazing. The matrix of combination here is huge. That was a fascinating talk. Thank you, Trevor. Thank you for having listened to this episode until the end. See you next time, next Friday in your podcast application. But now, go build.